Hello friends, today we are going to see about the reduction of quadratic form to canonical form. So this video I have explained in English. Already we have seen how to reduce a quadratic form to a canonical form. Then we have solved an example. So here is another example for how to reduce the quadratic form to a canonical form by orthogonal reduction. So question is, reduce the following quadratic form to a canonical form by orthogonal reduction and find the rank, index, signature and nature of the quadratic form. So the question is minus x square plus y square plus 4yz plus 4zx. So we know what are the steps to reduce the quadratic form to a canonical form. First step is we want to find the matrix of the given quadratic form. Then we have to find the characteristic equation. Then we want to solve the characteristic equation and we want to find the eigenvalues and eigenvectors. Then we want to form normalized matrix. Then we want to find the n transpose. Then find an, and last find d equal to n transpose an. Then at last we will find the canonical form. So first step is matrix of quadratic form. So here we have written the given quadratic form in a form of a matrix. A equal to minus 1, 0, 2, 0, 1, 2, 2, 2, 0. This is the matrix corresponding to a quadratic form. So first one is the coefficient of x1 square. So here we have minus 1. So here minus 1. So then half coefficient of x1 and x2. So here x1 x2 is nothing but xy. So here we don't have any xy, so it is 0 here. So here also it will be 0 because it is yx. And third one is half coefficient of x1 x3, that is nothing but here x and z. So we have x and z, that is 4. So we want to divide by 2, so 4 by 2 is 2, and here also it will be a 2 because these two are same. So next x2 x1, that is nothing but y and x, it is not that, so it is 0. Then coefficient of x2 square here y square, so y square is 1. Then half coefficient of x2 x3, that is y and z. So here we have 4, so 4 by 2 is 2, so here also it will be 2, here also it will be 2 because it is x3 x2, that is zx. So last coefficient of x3 square, so here is a z square, so we don't have z square, so it is a 0. So this is how we write the matrix of a quadratic form. So from this formula we are writing a quadratic form that is given in a matrix form. So next step is to find the characteristic equation of A. So you know the formula A minus lambda I equal to 0. So here I have, in a shortcut I have find the characteristic equation. So for that the equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So here s1 is nothing but addition of the main diagonal. So minus 1 plus 1 plus 0. So it will be a 0. So that is the S1. So S1 will be the addition of the main diagonal elements. Okay. So lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So the shortcut, it will be like this always. Okay. So here S1 is nothing but the sum of the elements, that is the main diagonal. So next one is the S2. So S2 is nothing but we want to find the minus. Okay, so for minus 1 we know the minus 1 to 2 0, and for 0 it will be, that is for 0 it will be, that is for a main diagonal alone we will find the minus. So for minus 1 this is a minor, for 1 if you take it is minus 1 to 2 0, then at last for this one it will be minus 1 0 0 1. So here if you multiply 0 minus 4, so here 0 minus 4, here minus 1 0, so we will get minus 9. Okay, see, remember that S1 will be the sum of the elements in the main diagonal, S2 is equal to that is minus of the main diagonal element. So for each element in the main diagonal you want to find the minus that you want to add, that is S2. So S3 is the determinant of the A. So minus 1, 0, minus 4, and for 0 it will be fully 0. Then for last one 2, her 0, minus 2. So plus 4 minus 4, it is 0. So here we know the thing. Here lambda cube S1 is 0, S2 is minus 9, S3 is also 0. So you will get lambda 3 minus 9 lambda equal to 0. Okay, see here that is how to find the determinant. Minus are already explained in the previous video, so check it. Okay, so third step is we want to solve the characteristic equation. So the characteristic equation is a lambda 3 minus lambda 9 lambda equal to 0. So here we are taking lambda as a common. So lambda square minus 9 is equal to 0. So lambda is 0 and lambda square minus 9 is also equal to 0. So lambda square is equal to 9. So we can get, so if you're taking square root, it will be plus or minus 3. So lambda is equal to minus 3 plus 3, here it's 0. So the eigenvalues are 0, 3, minus 3. Okay, so next we want to find the eigenvector. So eigenvector, you know, a minus lambda I into x is equal to 0. Here x is a x, y, z. Okay, LM, that is variables. So A is a given matrix, that is the given matrix. Then lambda identity matrix, I is identity matrix. Here we are reducing this. Okay, so we are taking lambda inside. Then in next step we are taking lambda inside. Okay, so minus 1 minus lambda. So other things are 0, so it will be same 0, 2. So here it will be a 0, here also 0. So here 1 minus lambda, then 2. So next 2, 0 minus lambda, so minus lambda. So xyz is a 0. So this is the thing we have get. Here we are going to substitute the eigenvalues to find the eigenvectors. So first eigenvalue is lambda equal to 0. So here we are applying lambda equal to 0. So lambda is equal to 0 mean we will get the same equation as the matrix. So we are get that. So this is the lambda equal to 0. So here we are reducing it as an equation. So minus x plus 2 is equal to 0. Here y plus 2 is equal to 0. Then here 2x plus 2y is equal to 0. So you know, so we want to multiply like this. Okay, each row and column, each row and column. Okay, so here how can we solve it is by using a cross multiplication method. Okay, so first what we are doing is first we are taking the first 1 and 2 in equations. Okay, this we are solving by a cross multiplication. So what you are going to do is, so first x element, so x is a variable, so that you are going to take. So for getting x, what you will do mean you will leave x. Okay, so you want to write the constants in front of that y and z. Okay, so y here it is 0, so I have written as 0. So z here it is 2. Then here y is 1, z is equal to 2. Okay, so how we want to multiply mean, so for x element we want to leave the x and we want to write only y and z. Okay, so if you are multiplying here, 0 into 2 is a 0. So here if you are multiplying it, you will get 2. Here we will get a minus 2. So it's a minus will come there when you are multiplying here. Okay, so you get minus 2 equal to, next you are going to take y. So y mean you want to take only the z and x. So already here we have written z. So here we are writing only the x. So x here is a minus 1, here is a 0. So minus 1, 0. So here when you are multiplying 2 into 0, 0. Here minus 1 into 2 is minus 2, but already we'll get a minus here. So plus 2. Okay. So next one is you want to find z. So here z mean you want to leave z, you want to write x and y. Okay. So here already we have written x. So here we want to write only the y. So I have written x here again. So y, you know, first one is a 0 and next one is 1. So here multiplying minus 1 into 1, minus 1, so it's 0. So here minus 1. So we get x, y, z, that is variable as a minus 2, 2, minus 1. This is an eigenvector for lambda equal to 0. So next you want to find another the next eigenvector, that is for lambda equal to 3. So when you are substituting lambda equal to 3 here, minus 1 minus 3, it's a minus 4. So 1 minus 3 will be minus 2, and for minus lambda it is minus 3. So this is how you will reduce it, and you will get a equation like this. Okay, so here again you want to reduce, so minus 4x, so it will be 0, plus 2 is equal to 0, minus 2y plus 2 is equal to 0. Similarly here 2x plus 2y minus 3 is equal to 0. So here also same, by cross multiplying we are going to find the eigenvector. So here also we are going to solve by cross multiplication. So we get 4, that is 4 and 5 only we will take. Okay, so 4 and 5, you know, this is the equation. So here you see x, you have only minus 4 is there. So here x is 0. Y, if you take here it is 0, here minus 2. So z will be 2 in both the sides. Okay, so based on this we are going to solve this equation. So I have written here already. Okay, so for x we have written a y and z. Okay, so 0 minus 4, already we will get a 4, so it's a plus 4. Next for y, so we are written z here, I am written x here. Okay, so here we are multiplying it, 0 minus 8, so we will get plus 8. So next for z, we want xy, so x is there, so I have written a y here. So 0 minus 2, again we are multiplying, plus 8, so 0. So if you take here, what we can do mean, we can take we can divide by 4 all the things, so we'll get 1 her 2 her 2. So the x2 is a 1 2 2. This is an eigenvector for lambda equal to 3. So next is lambda equal to minus 3. So in the same equation we are going to replace the lambda by minus 3. So if you are replacing minus 3, you will get this as the equation. Here also we are going to multiply inside. So 2x, so here's 0, plus 2 is equal to 0. Next here 4y plus 2 is equal to 0. So 2x plus 2y plus 3 is equal to 0. So here also the same method, solve by cross multiplication we are going to get. So 7 and 8 we are taking. So first one we want to write only the y and z. So for first y is equal to 0, second one is a 4. Here in this equation z is 2 2. So I have written here, so multiplying 0 2 is 0, her 8, so minus 8. Next y, so for y we'll write x and z. So I have written here z is there, so I have written x. So x is 2 here, her 0. Okay, so multiplying 0, her minus 4. Then for z, x and y, so I have written y here again, so 8 minus 0. So here also we are taking a 4 outside, so 2 1 4. 2 1 2. Okay, so 2 1 minus 2. This is an eigenvector for lambda equal to minus 3. This is the eigenvector matrix, 2 minus 2 1 1 2 minus 2 2 1 minus 2. So next step is we want to find the normalized matrix. So normalized matrix is nothing but what we want to do mean, we want to take a square of this all things. Okay, so here if you take 2 square is 4, minus 2 square also will be 4, plus 1, so you will get 9, root of 9, so root of 9 is 3. So we are going to write 2 by 3. So all the elements you are going to write like that. Okay, so here also we are having 1 2 2, so 2 square 4 4 9. Here also if you are taking square it will be 3. So here also 2 square 4 plus 1 plus 4, so 9. Here also if you are taking root of 9, so 3. So normalized matrices, you are writing the eigenvector matrix by the square root. Okay, so 2 by root of 9 will be coming all the places, we are going to write as 3. So 2 by 3 minus 2 by 3, 1 by 3, 1 by 3, 2 by 3, 2 by 3, 2 by 3, 1 by 3 minus 2 by 3. So next, finding n transpose. So n transpose is nothing but we are going to write the rows as a columns, columns as a rows. So anything you can do. So this column is, this row is taken as a column here. Similarly, this row is taken here as a column. Last row is taken as a column. So this is the n transpose. So transpose is nothing but we are transferring a rows into a columns or columns into rows, anything. Okay, there is a n transpose. Okay, so next find an. So an means the matrix which is given into this n. So we are going to multiply this. So multiplying you know already. So we want to multiply this with this. That is first thing, and next with this one, and next with this one. So similarly this row with this column, this row with this column, this row with this column. Similarly, last row with this column, all the columns. So each row will be multiplied and will be written like this. Okay, so each row with each column. So when you are multiplying, you will get like this. Then you are reducing it. So when you are reducing, you will get this is the answer 0, 0, 0, 1, 2, 2, minus 2, minus 1, 2. So this already we have explained already. So I didn't explain it. If you have any doubts, just write in the comment section. Okay, so next we are going to calculate d equal to n transpose an. So n transpose we know, an we have calculated. Similarly here also we are doing this. So here we know, here the first column is 0. So when you are multiplying, all things will be 0. So first column will be 0. So next we are taking this one with this one. So you'll know 2 by 3 into 1, 2 by 3. So minus 2 by 3 into 2 is minus 4 by 3, 1 by 3 into 2, 2 by 3. Similarly this row with this column, so minus 4 by 3 minus, so plus 2 by 3. So 1 by 3 into 2, 2 by 3. So next, if you take second row, you want to multiply here. So 1 by 3 into 1, 1 by 3. 2 by 3 into 2, 4 by 3. 2 by 3 into 2, 4 by 3. So similarly, this row with this column. So minus 2 by 3, minus 2 by 3, 4 by 3. So next, last row with column is here 1, 2 by 3 into 1, 2 by 3, 1 by 3 into 2, 2 by 3, minus 2 by 3 into 2, minus 4 by 3. So similarly last thing, so minus 2 into 2 by 3, minus 4 by 3, minus 1 into 1 by 3, minus 1 by 3, 2 into minus 2 by 3, it's a minus 4 by 3. So here we are going to reduce. So if you are reducing here, all will be 0. This one is 0. So here will be 0, here will be 0 because minus 4 by 3 plus 4 by 3 will be 0. Okay. So next here also is 0. So only this 2 will get. That is 4 plus 4, 8 plus 1, 9. 9 by 3 is a 3. So here it's a minus 9 by 3. So it will be minus 3. So this is the D. So this is the canonical form. So y1, y2, y3 into d. So y1, y2, y3. So here we are replacing d by the d what we have found now. Then we are going to multiply. So this row into this column will be 0. So this row when you are multiplying here only you have 3 only. So 3y2. Here when you are multiplying it is minus 3y3. So then you are going to multiply with this. So 0 into y1 0, 3y2 square minus 3y cube. This is the canonical form what we get. Okay, so then they have asked about the rank, index, signature, and what is the nature of the quadratic form. So what does mean by rank? So do you remember that? So it is nothing but number of square terms. Okay, we have two square terms here, so rank is 2. So next one is the index. So index is number of positive square terms. So positive square terms mean we have only plus only in 1. So it's a index is 1. So next is signature. So signature is we can calculate by formula. 1 is 2 is minus r, or we can write as difference between the number of positive square terms and negative square terms. So positive square term is 1, negative square term is 1, so it will be 1 minus 1 will be 0. So here 2s minus r mean this s is nothing but the index. So index we know it is 1, it is a rank, so it's a 2. So 2 minus 2, signature is 0. So next one is the nature of the quadratic form. So you know how to find the nature of the quadratic form. So nature is, so we should determine only from the eigenvalues. Okay, so if all the eigenvalues of a matrix are positive, it is positive definite. If the all the eigenvalues of the matrix are negative, it is negative definite. Okay, so if at least one eigenvalue is 0 and one is a positive, then it will be positive semi-definite. One is a negative, but one is 0, it's negative semi-definite. Okay, so here if you see the eigenvalue, it is 0, 3, minus 3. So you will have 0, you have positive and also negative. So all the things are here, so it is a indefinite. Okay, so this is about the nature of the quadratic form. Okay, so here we have just solved an example for the reduction of the quadratic form to canonical form. So we know the steps. So first step is we want to find the matrix, then we want to find the characteristic equation, eigenvalues, eigenvectors, normalized matrix. Then you are going to take the transpose of normalized matrix and A into n, then D equal to n transpose an. Then we want to form a canonical form using this formula. Okay, this is the steps how to reduce the quadratic form into a canonical form. Okay, if you have any doubts, you can pin in the comment section. So her just in another example. Okay, so because in a previous problem it is different, so we have repeated eigenvalues, so we have solved in a different way. This is a different way. Okay, so some members they have asked about how to solve it, and you should explain in English, so I have explained this in English. If you have any doubts, you can just pin me in comment section. Okay, okay students, thank you.